Do I wait for your signal? Okay, all right, that's the signal. So I realize I actually, even though I'm supposed to introduce Alex, I actually don't know most of you in this room. My name is Mike Wagner, so I'm going to introduce myself, and then I'll introduce Alex. My name is Mike Wagner, and about 3-ish years ago, I came here from NREC, which is where I normally am, which is why I don't know enough of you. You should all come out to NREC and take a tour. About 3 years ago, I gave a talk here about the work that I do in verifying and validating software for autonomous systems. And I think a little bit after that, I ran into my neighbor Alex on the playground of the elementary school that our kids all go to. And we started talking about autonomy and what it means to even verify autonomy. And I can say that I've learned a lot of really interesting and important things in my research, but I've learned a tremendous amount from Alex, and every time I talk to him, I learn more. So thank you for that. And so thanks for everyone for coming out, and I look forward to hearing what Alex has to say. Alex is a professor over in the philosophy department here. He's very accessible, so I'm sure that many of you will have a lot of interesting follow-up conversations with him, and you'll get a lot out of it. So thanks, Alex.
Thank you, Mike. That goes both ways. I always enjoy talking to Mike. And in fact, coming over here, I thought it's a tremendous opportunity to start some conversations that I hope that we can continue. I know some of the people in this room, and we've had valuable conversations that I want to continue. So there was too many things to talk about. I had to try to figure out what to say. And I wound up not limiting myself to one thing. I'm gonna try to have one coherent line of thought, but basically 3 different things that I'm gonna talk about. But so I want to talk in general about how values structure decisions and why moral dilemmas are probably not a good way to go about understanding this. Moral dilemmas seem to have a kind of outsized role in the conversation about ethics in AI, autonomous systems, and so on. And in a certain sense, the talk is a reaction to that. So I want to talk about how automated systems embody values and the way that they can be invisible or obscured because they get encoded or embodied out of a complex division of labor between the designer, the machine, and the user. I want to talk about how some ethics algorithms don't capture a huge range of moral perception and moral reasoning that goes on, and that would have to go on in order to use those algorithms. And so in that sense, what I'm trying to do is realign the focus of our discussion when we start talking about ethics in AI or automated systems and so on, away from what's the algorithm that's going to do the moral computing to how can we get these systems to navigate something like the space of information that makes up the moral world. And so that's really what I want to say is going to be involved in the challenge of autonomy for ethical decision making. So let's start out. So the first question is, are there really moral decisions? Are they a specific or a special type of decision? Because it seems from the literature like the answer to that is yes. Right now, society is sort of on fire about what's going to happen when autonomous systems start making moral decisions. And then you hear, well, when they start making moral decisions, we're worried about what that's going to mean for life and death. Does it dehumanize people? How will we apportion responsibility? How will we apportion blame? Is there a notion of guilt that goes on when an automated system is making moral decisions? So that makes it sound like we're on the cusp of something that's not necessarily happening now. Once it starts to happen, all these questions will kick in. At the same time, then it seems like there's a literature about specifically moral algorithms or moral decision-making processes. So just for the purposes of the talk, Anderson and Armin, in a relatively, for AI standards, relatively old paper, I guess, have 2 moral algorithms that they describe. One is Jeremy, after the philosopher Jeremy Bentham. And basically, to implement Jeremy, you have to look at everybody who would be affected by a particular decision. You have to look at the acts that are available to you for that decision. You need for each person to look at the intensity, duration, and probability product of pleasure that would be generated by that act for those people. You need to then sum up the pleasures for the products of those pleasures for all the people who are involved, and then pick the act that has the highest sum. And so you're doing a lot of that by data entry, and sort of the algorithm is really just doing the computing in a certain sense. Slightly more interesting for my mind algorithm is the algorithm they call WD after the British moral philosopher W.D. Ross. And it's sort of similar to Jeremy, except that it's looking for a weighted sum of 7 prima facie duties. So the human user has to go through and look at these different prima facie duties. There's justice, there's fidelity, there's beneficence, and so on. And then in a situation say, well, which of these is relevant? You give them a score, and then the algorithm aggregates that. And Jeremy has a little bit, WD has a little bit more flexibility in the sense that you can ask WD what the weights would need to be in order to arrive at the decision that you want to arrive at. So there's a little bit of bidirectionality in WD. But for my purposes now, this gives the impression that like these are things to make moral decisions, and that a lot of other things are not necessarily making moral decisions. So, should our machine A mow the yard in a circle pattern or in rows? That seems like it's sort of a non-moral decision. And what path should it take to deliver the medications to somebody? That also seems like a non-moral decision. So it sounds like we've got these 2 bins. And in the other bin is a dilemma. Right? Should the machine kill 1 person to save 5, or should the machine allow 5 to die and refrain from all killings? This is just the schema of the trolley problem, which is it's somehow escaped the confines of the biohazard lab we have in philosophy, and it's run out into the world now, and everybody's chasing down the trolley problem. So, but that seems to be what people think about when we think about moral decisions. So this is the sort of thing. Okay, so I want to have a slight digression now about moral dilemmas, because I want to move us off moral dilemmas, but I have a couple of things to say about them. So number one is there's a lot of sloppy usage when we talk about what we mean by moral dilemmas, and this is a problem. Sometimes we just mean valenced choices, where valence just means it's a choice that's got some emotional, it's difficult motivationally for us, or it's laden with emotion. When my wife and I had to put down our dog, who was 15 years old, Murphy was a great dog, there was no difficulty to that decision as a moral decision. It would have been cruel not to put Murphy down at the time that we did put him down, but it was a very emotionally difficult decision, and one that we sort of had to live with for a while, but there was no dilemma about it. It wasn't a hard choice. So a hard choice is something where at some time it's unclear how to reconcile the requirements or the norms that are in force for that decision, but where it might be possible with inquiry by some time bound of the decision. So I make a promise that we're going to go and do a project, and all of a sudden some emergency comes up, and now I have a hard choice. Can I fulfill both my obligation to the person I made the promise to and respond to the emergency? And with inquiry, it's entirely possible that I find some win-win solution, where I have somebody else discharge my obligations to the promisee, and I'm able to respond to the situation. So that would just be a difficult decision. A dilemma is going to be when the requirements on choice in a particular context can't be jointly satisfied. Now, you can have contingent dilemmas where they can't be jointly satisfied within the bound on time under which the decision has to be made. But perhaps if you had more time, you could figure out what the right solution would be. And then you can have just in-principle dilemmas. There's an irreconcilable conflict between moral principles or moral demands, and there's no way I can get out of that situation without violating one of the moral requirements. So The lighting isn't good here. I don't know, can you see all the colors, right? But, you know, so it's probably the case that all moral dilemmas are hard choices. It might not be the case that all hard choices are valenced choices. All moral dilemmas are probably valenced choices, but I think you can have valenced choices that aren't moral dilemmas. And in a certain sense, the rest of the white could be, it's entirely possible that there are moral decisions that aren't really even valenced decisions. So I wanted to say that partly because, you know, so right, this is Sophie's choice. Sophie is presented with a moral dilemma. She has to choose which of her children she's going to hand over to the Nazis. And to some degree, we don't really solve moral dilemmas, and that's a misnomer. We talk about that, you know, how are we going to solve these things? But if it's a genuine moral dilemma, you know, the problem for Sophie wasn't necessarily how do I make this decision. The problem for Sophie was that having to make that decision is itself a moral assault. Like a healthy society isn't a society where people face a lot of moral dilemmas all the time. A healthy society is where you've engineered social relationships so that people don't have to navigate moral dilemmas. And so just having to make that decision is part of the assault on Sophie. And I think that our fixation on moral dilemmas now as what we mean when we talk about, you know, AI doing ethics skews what it is that we think that we're doing in a way that I think is unhelpful. Okay, this is a genuine digression. But if there are genuine moral dilemmas of the sort that I describe, maybe there also need to be dilemmas for machines as well. If our performance measure that the machine uses, or the objective function, you know, that the machine uses is just optimizing a utility, then it's not going to be the case that that machine ever faces a moral dilemma. It might face options that it finds equally valuable, and so then it has to pick. But I'm not sure that such a machine is ever going to face an actual moral dilemma. And then that'll be interesting, because then how will that sort of system relate to us? Will that system ever face valenced choices, or will it recognize that we face valenced choices? Also, optimization takes a very strong position on what the structure of morality looks like. So this is just by way of advertising. I mean, Adam Bjorndal, Kevin Zollman, and I have this paper about how it is that we might try to model Kantian decision-making under uncertainty without violating the fundamental norm in the Kantian moral universe, which is don't treat people like they're things. And one of the problems of a utility function is that the way that it works as a machine is by assigning basically a commensurating value to everything, and then lining all of that up on one dimension, and then you choose the thing that's the highest on that dimension. Well, if you have a...
But what is interesting is when you ask people about the famous trolley problem, they will make a decision in all these empiric studies and so on, and they will not say, well, you know, I cannot make a decision, right? I refuse to make a decision. They usually will make, as you know very well, other utilitarian decision, you know, on the 5, and of course double, you know.
But look, so but I don't want to dwell on the trolley problem, partly because so let me get to partly because of this slide, right? That I think in ordinary life we have a lot of the interactions that we do because they're structured by values that are invisible. You didn't walk into this room. No, I didn't see anybody walk into the room and try to sit in a seat already occupied by another person. Now that might be a very efficient way of stacking people into rooms. I mean, I'm competing with Summer, another talk at Pitt, you know, the topic of the talk, and all sorts of things. But you know, had we had a smaller room or better attendance, then we might have needed to stack people that way. And had I said, just sit on the lap of another person, you might have been like, wait, I'm not sure I'm so comfortable with that. So that suggestion might have brought out to you now something salient that's invisible that's structuring your conduct right now. Nobody tased another person in order to get the seat that they want, you know, further on in the back of the room, and so on. So there's all these sort of implicit values that aren't about solving dilemmas. They're about having smooth-going, you know, social relationships with other beings that have interests, whose interests might conflict with yours, where you have to solve coordination problems, all kinds of things like that. So I'm not sure that there are two bins. And what I want to say is the appearance that there are 2 bins is partly because we're doing a bunch of moral work in order to create these 2 bins. That's the key point I want to make. So, should our machine run over the neighbor in order to finish mowing the yard on time? It's not a hard choice. It's not a moral dilemma. I think we all agree the answer is no. And part of the reason why we don't put that over, the reason why we think the non-moral choice is non-moral is because we've built that in. We're saying, yeah, like, an effective machine won't be one that mows over the neighbor, right? That just goes into the criteria we're going to use for success of having a good lawn mowing machine. But we've already done a bunch of moral work there. What path should the machine take to deliver medications? Well, we need to have made sure that there's this other question. Should we provide a medication to somebody if it became too warm in transit? Some medicines need to be stored at a particular temperature so they don't either lose their efficacy or become toxic. So now if that would relate perhaps to the path that we take, and so it's something that we take into account, and our taking of it into account is kind of hidden because it's done at the engineering stage. So let me try to unpack that a little bit. When we think about tasks, we've got goals to achieve, we've got the means to achieve those goals, and then we've got constraints on both the goals and the means. And those encode values, and when we design products, the designer and the user, and perhaps whoever is, if there's someone who's also carrying out oversight who isn't the user, they also are looking at values in their construction or use or oversight of these machines. I'll skip that. So this is my problem. I can't draw, or I'm sure there's a tool that I should have used to actually get the right sort of 3-dimensional thing. So what I mean here is the bottom structure is the task. So it's got a particular structure to it. There's a pane that you're looking through. That's the design of the machine. The other side is the design or the designer and the user. And what I want to say is that the designer looks at the structure of the task, looks at the user and what the user's capabilities are, and then says, how can I make a machine that's going to allow the user with his or her capabilities to carry out that task, not do other tasks, right? Not make a whole bunch of mistakes. And then I'm going to use that information to design my machine, and the interface with the machine be one that the user can use to carry out the task. So the designer is looking at the structure of the task, using that to structure the machine, looking at the user also to structure the machine. And then the user's got some stuff they need to do in the use of the machine as it's been designed. All of those things, there's a division of labor there. In that division of labor, there's a lot of value judgments, perceptions, decisions that are encoded in that. A concrete example here now, across 2 different contexts, because I think some of these things get, the interpretable and inscrutable, I think, is less important than this notion of sort of a determinate context of operation, where there's a clear sense of we know what we want to do. This is just, my cruise control on my van. And it's like, my cruise control, it's, you can look inside of it, exactly what stimulus inputs, so I have to decide when to set it. Once I set it, then the machine knows what stimulus inputs to use to, activate the accelerator or to activate the brake. It's got a very limited job. It maintains a particular speed. And then I have to say, is this the right time to activate that or not? Are there other things in my environment that I might need to hit? I steer. You can have more complex forms of cruise control that take on more and more of those operations. But when I was a kid in Wyoming, and cruise controls were just sort of coming out, on vehicles that people had. People were, at least, where I lived, there was at least one case of somebody with a mobile home set the cruise control, thought it was like autopilot, went up to make an omelet or a gin tonic, whatever, and then, once there was a bend in the road, went off the road. So there's an implicit piece of information there about what that division of labor needs to be. It wasn't communicated, at least to that particular consumer, and then you had that bad result as a result. So in these interpretable approaches, basically there's this idea that there's some model that maps input stimulus conditions to output response conditions that's scrutable to us. We understand it. We can look at it. In the black box, your model's learned from statistical operations on some large array of variables, but the point is it's encoded in some structure that you can't really look at and go, this is exactly how it's working. You understand how it all gets put together and how all the inputs and outputs are associated, but it's not necessarily scrutable to you. So, the FDA just approved a standalone system that will do diagnostics for diabetic retinopathy. So the input will be a picture of a retina. There's some neural network that then does the processing and outputs a diagnosis of diabetic retinopathy or not. And so, this is it's an example of an inscrutable, machine, but I think it's still pretty much like we know it's doing a very narrow task. It's got a very carefully delimited diagnostic criteria, and part of the conditions on effective use are the sensitivity, specificity of that test, and conditions on what the photograph needs to be like, and other things where we're going to preserve the reliability of the processing. So all of that, I think we're leveraging our knowledge of the structure of these tasks, and we're leveraging our own values to make sure that everything goes well. And in a certain sense, I think Jeremy and WD are systems that are very similar to the ones I just described, because Jeremy and WD need humans to recognize that a decision needs to be made. Oh, something's happening. Okay, I got a moral decision now. Get me Jeremy, or pull up WD. I got to partition the world. Who's affected in this decision that needs to be made? What are the acts that are available to me as a response? What are the likely outcomes of these acts in this world? I have to detect whatever. You got to give me a conception of what value is going to be in these states. I'm usually the one, the user is usually the one in these systems that's detecting what that is. And then you're inputting the data to be computed. So the machine's doing some computing for you, but what I want to say is this is all moral perception and reasoning. So I see a head shaking, and so let me try to make good on that. All right. So the space of information for the kinds of systems I showed you earlier is largely, I can rely on some surface feature of the structure that I'm looking at, and I can leverage natural meanings, right? So like, here the snot coming out of the nose and the temperature on the thermometer are natural signs. They mean that the person is sick, where I can infer from those things to some underlying feature, namely that the person has a virus or a cold or something else. The space of information when we're making moral decisions supervenes on non-natural meanings. Non-natural meanings are the sort of things that, like, I'm communicating to you now. They're the things we communicate in speech. They're symbolic. They require a knowledge of the interests of the parties that are at stake, what the relationships are between the interests of parties and either events or acts. What are the sorts of things that are capable of affecting those interests? And what are the relationship between the interests that are involved? Do they all align? Are they all mutually satisfiable? Are there conflicts? So this is a little bit of audience participation now. I want you to imagine yourself in some outdoor environment, and somebody comes up to you and does this. Can you tell me what they're doing? Just shout out what you think. What's happening? I don't know. You don't know, right? This is what's happening. What do you think?
Trying to stop you?
Stop. Good. I like that.
There's 5.
There's 5. Yeah, I like that.
Where?
What's that?
Go away.
Go away. Okay.
They're showing texture of the hand. Color texture of the hand.
Colors. Yeah. Yeah. So now what happens to you if we say you have the following belief? The swing set was recently painted. That's just a belief you have. It's a current. And that person comes up and shows you the hand. Now what happens?
Well,
This is the vein.
Right? Now you might say, hey, something needs to be done now, right? The kids are on the swing set. Like, oh my God, you know, what's going on? I got to repaint the swing set. Or are the neighbor kids with them? I got to go out and do something. Okay, maybe it's not that. It's we're supposed to be at a fancy party in 15 minutes. That's the situation we're in. That's a belief I have. I know that. Now there might also be something to be done. I have to clean you up before we go. You know, what's happening? Someone made chalk drawings on the neighbor's driveway. Now I know it was you who made chalk drawings on the neighbor's driveway, and now this is where information matters. What are my neighbors like? If I have good relationships with my neighbors and their kids draw on chalk on everybody's driveway all the time, then I'm just like, there's no decision that needs to be made. I've just learned a piece of information about the world, but that's all. If my neighbors are curmudgeonly old people who don't like people drawing chalk on their driveway, and this is my child who's drawn chalk on their driveway, then I have a decision to make. How do I get out of heat with my neighbor? What are the acts available to me to go diffuse this situation now, right? Should I go talk to them? Should we put you in witness relocation? You know, what are the options that I have? And some are going to be better than others. What if it's that my belief is that that person knows I like teal. And they're showing me teal. I like teal too. Right? Or they know I like to paint with chalk. Okay, my point here is I can modulate your perception of what happened and what the likely states of the world are going to be given what happened, and what you might want to do as a result of that by just toggling this one dimension, what the current belief state of your system is. I can change now what are the roles of the agents, right? This is your foster child. This is the babysitter. This is a detective. This is your new neighbor. This is a chemistry teacher or an EPA inspector. Now you can imagine a mapping from beliefs on the previous page to some of these role things, and further change or add context to what's going on, what just happened, what might I need to do, what are things I should expect to roll around. Oh, this is an EPA inspector. What did they find now? Why was an EPA inspector here? All those things structure my perception of what happened. What act occurred? Are we pretending? Are they commanding? Stop, go away? Are they confessing? It was me. Are they inviting? Come on, let's play. Are they inquiring? Did you see this? Or like, you know, did you paint you're the one that painted the swing set right before the party? Really? Are they tempting you? Come on, don't you want to do this? Or spite? Yep, boom, I did it. And what's their goal? Are they warning you? Are they trying to have fun? Are they trying to make a new friend? Are they seeking assistance? Are they trying to explain something? Are they out for retribution? Okay, so these are 4 different, right? I've got goals, acts, roles, and beliefs. And then the interesting thing is, maybe there's 2 or 3 of those that you might feel relatively confident about, and you'll try to infer the 4th one. So these things work in a network like that. And what I want to say about them is that they're value-laden and that they're at work in the perception of what just happened, putting a partition over the space of what state am I in, what parts of what should I expect in the future, and what acts should I think about or contemplate. That's what I just said. So I think they structure what happened, and they help us draw these partitions. This is important because one of the ways that we can go wrong in life is moral blindness. So it's that we don't recognize that some agent is implicated in something. We don't recognize that the interests of some agent are so I know you're involved, but I don't know that you have a particular interest that has now either been transgressed or is at risk. Maybe I fail to recognize which default norms are at stake. what responses those norms require in the context, or what the menu of acts are that I need to be evaluating. So, one of the things is we use trolley problems as thought experiments where we sort of say, listen, let's create a world where we take away a bunch of stuff, and so we can force, like as we do when we sanitize, experiments, we can force a judgment. But like out in the world, if there was an object rolling towards a bunch of people and you were standing that close to it, and it was one that you could push off the track, and you go, oh, it's a trolley problem, we'd be like, I don't care how you solve the trolley problem, the right answer was push it off the track. Right? Like, your partition of what things are available to you, I'm sure you've been yelled at some point for not recognizing that you didn't think about what the right action to do was in response to something. I don't know if you can see this, it's kind of small, but so in this sense, I think part of what's relevant here is I think we tend to think about, there's a lot of discussion about should we have a top-down approach where we've got a robust moral theory and then we start with that and we make judgments. Should we have a bottom-up approach where what we have are a bunch of particular judgments about cases and we try to knit together a theory out of that? And in some work I've done about how we ought to think about applied ethics in those things, I think it's relevant because it seems to me that really what we have is a kind of common store of capacities to detect interest and relations of acts and states to interests. And that helps us frame decisions. That helps us make judgments about particular cases, and we use that when we construct theories. I mean, when we construct theories, part of what we're doing is we're trying to decant out and articulate explicit moral principles that have some plausibility. They're going to cover a bunch of these cases, and maybe the cases we have to change the cases because our intuitions aren't as clear about them. But at each case when we're making those adjustments, it seems like we're drawing on this same underlying set of capacities. So what I want to say then is if we're increasing autonomy, if increasing autonomy means allowing machines to take over more of the cognitive labor that is currently resigned or allocated to the human user, then fostering autonomy is going to require giving machines greater access to this space of moral information. So either we're going to do a better job of carving that space up so that the machine has pre-masticated signs and signals, stereotype things that it can more reliably condition on and do well, or we've got to give it greater access to things like what are the human interests that are at stake in this domain? What are the causal properties of the things that you can do or that you can cause in the world, and how do those things bind to, as it were, those interests? If you want to use a kind of receptor, metaphor, how can the things that you can do affect or relate to the interests that are at stake? And perhaps then some stereotypes about default expectations. What are the sort of clusters of expectations that arise in stereotyped situations? Because in a certain sense, that's what I was eliciting from you with that photograph. Okay, so I was thinking I could stop there, but I've gone fast enough. I do want to raise this last issue, and then really what I'm looking forward to all the conversation. But so here I mentioned like stereotypes of default expectations. So let's just say that a default is something like a set of values that are going to be enforced for an agent in a context. And that different contextual features might structure that set of values differently. So if I've made a promise, then it might be that the promise there's some claim on me that I have to live up to the promise. And if I'm not going to live up to the promise, then I don't just go, well, I broke the promise. Other things are then incumbent upon me that I have to make recompense or find a way to help you out or do other things like that. And the interesting thing is it's not clear to me that there's a kind of independence between what those defaults will look like and the nature of the agent that's engaging in the situation. So this is another layer of complexity because I want to raise the possibility that machines that have access to different data or forms of influence that might actually alter the nature of the moral defaults that we face in particular circumstances. So let me give you an example of what I mean. This is the last thing I want to say. So consumer relations are an arm's length relationship. So go before computers. Consumer relations are an arm's length relationship, and usually the way that I try to get you to buy my fancy wares is by telling you that they're better than they really are, or leading you to believe that they're better than they really are. And then you as a consumer, you know, caveat emptor, that you have to be on your guard. Yeah, everything I say is cheap talk. You're not going to listen to me. I'm the guy trying to sell you that thing, right? And so savvy consumers know that's how that goes. But if we can now leverage large data sets so that we can alter customer behavior without altering your preferences, then the question would be, does that shift the default? Because I haven't changed your valuation of good one or good two, and I haven't necessarily altered your beliefs about good one or good two. But if my knowledge of the way that you go through my store is such that I just say, putting things at eye level just increases the probability that you're going to buy it, as opposed to if I put it down low, now I have a choice. What do I put at eye level? Because if I put it there, you're more likely to buy it, even though I haven't necessarily changed your beliefs about it. If that's actually the case, then there's a question, is this still a kind of adversarial relationship where caveat emptor? Or if I now, because I control the environment, can alter the choice that you make, do I now have some moral responsibility for the choice that you make? This is what the nudge people are really on about. And perhaps the default here should be something like a healthier choice for you. Right? The default could be an more expensive product, so more profit for me. Or it could be that I monetize that and then I sell to the highest bidder, hey, if you want your product at eye level, you need to give me some sort of kickback or compensation or something like that. But we might ask, does permitting that kind of commodification of that kind of influence really advance our interests? And that might be different, in a certain sense. The idea might be an agent, a computational agent that has that kind of information, has information that you and I don't have. And so the kind of relationship that we have to that agent is different than the relationship that we have to one another. So even if we understand what the structure of the relevant defaults are, it doesn't mean that that structure would stay the same if we introduce agents that work differently than the way that we do. Okay, so that was a lot. Thank you for listening, and I look forward to the questions and answers. I don't know. What's your custom?
Go to him. I can ask anything. Yeah, so just sort of directly off the point that you ended with.
Yeah.
So sort of, I guess maybe a way I would push back. It would be to say that, like, sort of, if a customer doesn't know, you know, sort of in the original situation with sort of it's just shop talk, a gullible customer would sort of be just as vulnerable. So is this a new situation, or is this sort of just a different type of shop talk that, like, societally we just have to get used to and know to account for?
Yeah, right, I don't know. That's a good question. I mean, in a certain sense, you'd want to say something like, can we arm customers with the knowledge that, listen, you don't realize, but a lot of your choice behavior is shaped by the way we organize the environment, and we just want you to know we've organized this environment so that we're going to profit maximally from your default choice behavior. So if there's cheaper products that you want, you might have to look for them in less convenient places, right? And then I just don't know whether people would go through and they would come out with the same budget, or whether they'd just be like, wow, like the economic cost now of foraging for these cheaper products is just so high that, yeah, I've wound up spending more money. And I look, and it's also an empirical claim, like, did my beliefs and values not change, you know, in that process? Or was it that I just said, oh, I've never seen this product before, and its wrapper is shiny, and it says it's natural, and, you know, I'll pay a little bit more for natural.
I was just wondering if you could speak a little bit to the question about whether or not this is just a matter of, like, opening up frames and opening up more and more frames and sort of collecting more information to understand context, or whether there's something that can't be solved by doing that. Because, like, you were talking about understanding intent, and I was starting to write down examples of, like, if we're trying to observe, say, in a camera or in a video, what people are doing. Like on a simple way, you might just be observing inferring what they're doing based on, their direction of motion or some sort of like direct physical thing. But all these other kind of background contexts can be a lot more accurate, certainly. And so then I wonder, it's like, well, did I just need to like learn more about them and watch them for longer, or is there something else here that we can't capture that same way?
Yeah, so I guess it seems to me there's a difference between saying what's the, what was the path of your motion 2 seconds ago, and let me predict what your path of motion is going to be 2 seconds from now. Because there, I want to describe that as like I'm leveraging some features of the surface structure that's available to me, like a gross feature of the surface structure. And between saying something like, even if I had a primitive model of what it is that you're trying to do. So I guess what I'm after is, can we have what would be a primitive model of you're trying to get to the door? And given that I know you're trying to get to the door now, why are you over here in this spot? Right? What must have happened to you to get you over in this spot? Or, really good example in the driverless car space would be, you're in front of me and your blinker is on, and you drive by a road. Now, like, I'll be like, wait, are you lost? Are you not from around here? Something like that. But I'm going to be making inferences about what it is that you're doing. And so what, in a certain sense, I think, what I'd like to see would be, can you give me a constrained model of something like the purposes and vulnerabilities in this domain, where I could start to work with that information in trying to predict what you're going to do or interact with you, rather than, so in a certain sense that's a kind of deep structural thing. I might not be able to see that, but I'm making inferences to it from from the behavior of yours that I see. But there's certain things I need to know about you.
Yeah, so kind of like a gateway example that I see all the time. It's probably on the way in. There's a crosswalk right next to a bus stop. And so there's people sitting, there's traffic going, and there are people standing right there. And so if they're trying to cross the street, then I should come to a stop. If they're trying to wait for a bus, then I'm not supposed to do anything. And it's like, well, maybe if they have a bag, maybe if they look, and so part of me wonders, like, okay, if I'm trying to learn a behavior using some sort of, deep learning kind of thing, like, is it just that I'm not, like, I just need more examples? Is that the solution? Is that how we respond to what he's saying? Like, do we just need like even more dimensionality here? I actually don't know.
Oh, so let me add one to that, and then I'd love to hear the people's responses to that. But like when I'm driving, if I come to an intersection and there's like a pole bent off, broken off in the ground, and I can see traffic going in front of me, I'll go, this was a place where there probably was a stop sign at some point, right? Or I expect there to be a stop sign here. And maybe something happened to the environment. And so, that kind, now I don't know if you can get that with a bunch of counterfactuals, that I need a bunch of counterfactuals, or I need to know something like stop signs aren't just a particular shape or color, but they appear in particular places. But it's that kind of, like the amount of information that I draw on. So I worry that on the one hand it sounds like there's an infinity of information that I draw on when I'm looking at those pictures. On the other hand, it sounds like I want to say something like, well, that's true, but that infinity is kind of organized in a pretty neat way. Because, here I'm out of my own, depth, but certainly aren't I computing those things, and didn't I make those inferences? So there are things like
you would not have needed to search for them.
Optimize
for them. If your brain was like evolved into sort of making certain choices on its own, right?
Yeah.
So.
It's already hardwired.
Right. Exactly.
Perception is already hardwired. But the thing is, it depends on the goal, I think. One can have infinite thinking and all that, infinite computation. But first of all, it's not possible in terms of, at least the state of the art, to have infinite computation. So by necessity, if one needs to act, right? It's the satisficing and all that stuff. Of course, Simon said, because we cannot just, if all of us were thinking and making these inferences, nobody would be doing anything else. We wouldn't be doing anything else.
There'd be no trolleys
So,
moving. and
there
everything
wouldn't
would
be no things designed, no food prepared,
Yeah.
no
Oh,
nothing.
yeah, that
would be a
Everyone would be
Yeah.
sitting here infinitely thinking about
Yeah.
or moving around the world and saying, now what? So the point, practically speaking, right, is if we are going to have machines that wander around the world and work with us and so on, and have different interactions, what would be some ways that these machines can reason efficiently? Efficiently meaning, okay, some kind of computational complexity, but still, tractably. And are really effective most of the time. Because obviously people make mistakes all the time in terms of norms, in terms of etiquette, in terms of conventions, in terms of this, that, and the other. Plus the fact all these things are different in different cultures to start with. A lot of these things, right? And so you go to a different culture and then you can make many mistakes without having to, even though you may be thinking, but because you don't know. Right? So this, to me, I mean, is more like the issue for us at least, right? I mean, for robotics people that want to actually create models, computational models, for having these machines make decisions in certain environments. And I agree with you. I mean, I think you are saying that a lot of the environmental and contextual factors are the ones that give rise to, first of all, particular beliefs, but also particular norms, right? Particular decisions, but also particular norms. And so that, I think, is very interesting, and I mean, I'm subscribed to this, and I think it's very interesting to see, first of all, what may be this context, because they can, of course, prune the computational complexity, right? So I don't have to think about all the norms in the world to make the decision today whether to go shake hands with Mike, for example. So these may be something that would be, on the one hand, the way we as humans look at the locality of a situation every time. And also the byproduct would be to prune out, to make it more computationally tractable. And so that, I think, is one of the, at least practically speaking, one of the things that one may want to do. And then see, okay, how maybe different contexts maybe relate to others and so on. But at least in some particular context, I don't know what your
I think
idea is about that.
Well, I think part of this was just to try to shift the focus away from, what's the algorithm where we do the moral computation,
There's no algorithm, but at least one can have some kind of a model because So I mean, I can have a model without having an algorithm. I mean, I can write down for example, a set of equations without being able to find a solution, an analytic solution, right? So I could write them down. I have a model. I could make a logical model and say, these are my predicates, these are my arguments, these are my parameters, and I can write them down, but I may not have an inference procedure for those. So at least having a model is the start. Then we think about the algorithm.
Then you
of
buy
course,
the GPUs.
we need to, spend another 20 years to find the inference procedure, but at least you have some kind of a model.
I mean, look, there are certain things you get for free when you have, a machine that's interacting with people, and it's like, well, look, we're squishy meat creatures, so don't bump into us hard. And so it doesn't need to have a representation of our squishiness and what happens to us. You just have to design it so it doesn't bump into us. But as we interact with robots in more complex ways, then part of the question is, can we build in some of the background information that we leverage when we know things like, look, these are all-purpose vulnerabilities that people have across cultures. that these are ways in which you can activate those vulnerabilities. Because in a certain sense, that's what I'm talking about when I say trying to make sure that our machines are located in roughly like a moral space with us, right? That they're sensitive not to just, so the bumping around is great, but as we have things that are doing more tasks for us, they have to start to understand now, like or be able to, they don't have to understand, they've got to be able to navigate some of the purposes that are encoded in these tasks. And so what I want to, if nothing else, what I want to try to shift the goal when we think about ethics here is away from what, what's the things that we're summing, or are we multiplying, or, and go more to like, how is it that we start to have some confidence that our machine is aware of the morally salient factors in an interaction. It doesn't have to be aware of that in a kind of self-awareness, but it's aware in the sense of what we can say, here's the way that we go, here's the mapping that we use from things our thing can measure, and something like the relationships it posits between the things it can measure and states in you that are going to make sure that it doesn't do X, Y, and Z.
I mean, other people,
some of the reason why so many people have trouble with ethics and morality with robotics and some of the more large big data types of systems is that we're moving away from situations that are where the knowledge of something happening is more discrete, right? So if I'm a store owner and I lock my doors, fire escape doors, to prevent shoplifting or something like that, that's viewed as unethical, immoral, would be morally inappropriate, that sort of thing. And it's clear I did that one thing, right? There was a choice made to that was not correct. On the flip side, if you have, some deep learning system, and a social media system that is making recommendations that affect whether or not you buy things, and it's not entirely clear why that happened or how it happened, or if it's a robot, and I don't really understand its perception system well enough to understand it's not going to see certain things. There's this noise element that goes into this, uncertainty that goes into it. Now that uncertainty leads to my concern as to, well, why isn't someone doing something about this so we can create these sorts of structured do not do this kinds of things in these systems, right? And so you see this in traditional computer systems because there is no uncertainty, right? If then, right? But now we're into this space where there's huge amounts of uncertainty, and people are, I think, are uncomfortable with that. And what they're looking for is some way of being able to say, well, if this is going to put me in danger, I want to know that it is going to. I don't want the uncertainty of knowing whether or not this thing's going to hurt me. And I think that's where a lot of this tension is. And so that's why the moral dilemmas are so powerful for when it's a robot making the decision versus a trolley operator. And so what I'm getting at is how does this framework handle the uncertainty?
Well, I mean, so look, I mean, I have papers about exactly this question about uncertainty with like autonomous systems like the autonomous cars, and how that's very similar to how we cope with uncertainty in drug development, because there are interesting parallels. And so, look, I mean, I'm not sure at a certain extent that I have that much novel to say, to you, other than things like, with the old Palm Pilots where, it just couldn't read our handwriting, so we invented a new scratch that you would use, that it would. And so, there's always we want to have very stylized, stereotyped interactions with our machines. The machines have stereotyped, stylized interactions that sort of send a signal. I can do this blocky, 8-bit kind of thing, don't expect me to do more subtle things. So there you're trying to limit the environment and limit the set of expectations of the user. And in a certain sense, I think that goes back to the original diagram I had, where you want to reduce this to an engineering problem, where you say, how can I communicate to my user and design my machine so that there's not a mismatch in their capabilities, right? And that's an important and right now real thing we're dealing with. I guess that my interest was more if we take on this idea of autonomy that we're going to offload more of the decision making into the machine, then how far is that strategy going to take us? There's just a certain level of complexity, I take it, beyond which we're like, how many of these stereotypical scenarios can we have and handle and communicate? Like, is the insert on the machine going to be longer than the insert on my drug, right? Or I'm like, to get it to do this, make this stylized, movement or gesture or something where it becomes. Yeah, right. I mean, like, look, I can imagine certain of those things, right, that we'll probably change our environment around the roads to make them accommodate the kinds of systems that are on the road, right? But yeah.
Kind of going back to the example that you had regarding the farm.
Mm-hmm.
So the whole reason why we had that example was to talk about inference and then the context in which the inference can be made.
Yeah.
So I'm kind of wondering, do you have any idea or if you have any suggestions to think about in terms of the number of features that would be required in order to make that inference?
Yeah.
And more of a theoretical bound that would be sufficient in order to say with the confidence that this inference is correct.
So, I mean, one thing, just to change, so I bet that for us, one of the things that we would do in this situation is we'd formulate a hypothesis that we would test pretty quickly by asking a question or doing something like that. And so in that sense, I think there's a kind of recursiveness to this process where we have a kind of initial, equivalence class of worlds that we might be in, and then we sort of say, hey, were you on the swing set, or something like that. But we ask a question that's going to pull apart some of those worlds, and a lot of this thinking, actually, I think, people who are doing language and language processing and communication, a lot of our communicative habits are structured by this notion of, like, there's a question under discussion, there's common knowledge that we have, so we're not making everything explicit, right? What I say to you, I think, is sort of the least amount I have to communicate what I want you to, uptake, because I have some model of, like, what it is that you believe and what the point of our conversation is. And so in a certain sense, I think that kind of model would be really, really useful in porting over into the ethics context, because there's a kind of, what are the beliefs that we, there are analogs to what's common knowledge, what are the beliefs that we have, and what's the point of this interaction is kind of like, what's the question under discussion, and I think we use a lot of those things to simplify the problem. It isn't the case that, so in most of our interactions, it's not the case that the whole universe of possibilities is right there, right? Like, it'd be very odd if you raised your hand and you asked me a question about, marsupials, right? I mean, it's possible, but, like,
How about those penguins?
How about the penguins? So like there, so I would say it's more along the lines of, is there an analogous structure like that we could port over that would be involved in sort of structuring, instead of our linguistic expectations, which is also a highly normative activity, our normative moral expectations. That's not the kind of answer you were expecting, I expect, but it's the one.
Code on GitHub.
Yeah, I know.
No, I mean, but the thing is that here, so we have these beliefs and these defaults and so on, what you illustrated, but if you were to ask anybody else, is there any moral reasoning involved here, they would say no. I mean, you're talking to me about, the chalk and whatever, right?
Yeah.
So in some sense, it is indeed the stuff of human-robot or human autonomy interaction, right? And whether that is linguistic or it is, motion-based, gestural, or whatever else.
Yep.
It is basically interaction. And the issue then is, and that is one of the things that I'm not sure a lot of your colleagues agree, in terms of, are there really distinct moral decisions versus decisions in terms of for example, how do I go and ask my neighbor whose sidewalk my child may have painted or something like that, right? So in that sense, I mean, that's not a moral decision.
But why is that not a? I guess that I don't want to agree with that. I mean, whether somebody drew chalk, you know, if my belief is someone made a chalk drawing on the neighbor's driveway, and I see this, then whether I have a decision to make, whether I have to take action or not, is going to depend fundamentally on my values. Right? That if I value my child's welfare and I have beliefs about my neighbor, that this is something that links now the welfare of my child with the actions of my neighbor, then that should activate in my mind, I've got decisions I need to contemplate and states of the world that I need to avoid or try to steer myself to. Whereas if I have friendly neighbors who don't mind, right, then there's no decision. And part of what I worry about is when we think about matrices that come labeled with states of the world and acts that are feasible, there's already a whole bunch of cognitive labor that's been done there. And you know, so part of what I want to know is when you start out with a machine that's already got all that, you know, that's great. I'm just, you know, my question is something like, what can we do to figure out the way the machine might be able to detect I'm in this space and this is the matrix I need to use, even if it's just a mapping now from equivalence classes of matrices, right?
But this is what I was talking about when I'm talking about context.
Yeah, okay.
And this is exactly the point.
Yeah.
Context is one of the most pernicious ways, I mean, things that are, you know, we don't know how to represent context. Okay? Even in vision and even in whatever, people have tried to say, what is context, what is, you know, what is my background, what do I consider my focal object, and what do I consider my background, this background object, to which one should I pay attention? And that depends very much on what is my goal, what is the object, and so on and so forth. But if I'm going to represent context, and in this particular case, it's the social context, right? So of course the relationship with my neighbor, the relationship with, you know, what my neighbor is and so on has to be represented. Yeah. And so in that sense, it is very, very difficult, I mean, even to model it. That's why I was saying, what are my predicates, or what are my arguments, what are my things that I'm going to, and how am I going to determine these things? And these are all uncertain, and I don't agree with Aaron that said computation is, you know, if then rules, because even in the 80 years ago or whatever, when the expert systems were there, we did have against the paper and so on.
I think it was just 65.
Yeah. We did have uncertainty, even in the expert systems.
Right.
So the world is uncertain. So we need to take care of uncertainty for sure.
Yeah, sure.
So you've mentioned a couple of times sort of algorithmic decision-making being sort of a big step. Is that the sort of, like, if you're sort of thinking about, I know there's been a bunch of talk about like AI in general as sort of creating a big change, would you sort of pin it to the idea of sort of decision-making being sort of done more sort of technically, and sort of like, is that the biggest change that sort of brings up these questions, or is it, and sort of what aspect of it is it, it's sort of a shift from, so historically it was this sort of just in a continuum, and there's nothing new at all. I don't know if that quite made sense, but.
So I think this is an answer to your question. I mean, economists, forever have wanted to have a moral mathematics. So, I think in that sense, the computational aspect of it is just we've got a new purpose for wanting to look at that. But also now the sorts of techniques, evolutionary algorithms, or all this sort of stuff that all offers different approaches to these things. That's really new and interesting. And I think part of what surfaces this. So look, there's a different talk I have. Where I talk about this whole idea that machines aren't making moral decisions right now. It's just invisible to us. If you saw Hidden Figures, there's this amazing part of that movie where John Glenn wants this one particular woman to calculate his reentry trajectories, and it's like, look, you wouldn't go to NASA now and be like, I want this really smart person to do that calculation. You'd be like, dude, no, like you need to have the machine do that. right? And so it's like, that's a life and death decision that we've pushed over to machines. It's automated all the time because they do it better than we do, but it's sort of invisible now because it's kind of in the background. And the interesting thing about that movie was at the transition from human computers to computers, there was this sort of fuzzy, like, did we program it right? Is it going to do it? Like, are the punch cards going to get stuck? Or whatever. So, I think we already rely on these systems. It's just that the extent now to which there's the rhetoric, but there's also the extent now to which these, more things might be possible. And, with these, so we have incredibly effective systems that we can talk to. Alexa, buy me a house. I was at a party with a friend who has Alexa, and I was like, if I said, Alexa, buy me a house, he's like, Alexa, don't do anything. Stop, Alexa, don't listen to that guy. But you could say, reorder me my pencils, Alexa. And it's like, wow, that's tremendous, right? But, if you're like, if people think they can start to, the better these things get and people think they can talk to them like they can talk to other people, well, there's a lot of simplification that goes on. And there's going to be room now for sort of screw-ups there. And so I think it's just the perception that there's more at stake because we're relying on them more. And I think that puts more stakes on how we represent moral decision making. And that's why I think we should think about representing moral decision making much more broadly than just asking what's the utility function that we're maximizing, what's the score that we should be trying to optimize as we have all these interactions, right? I think we're time, so thank you for staying and coming.